Hello everyone, my name is Ved Patel and my ID is 24CS081 and my mate's ID is 24CS080 and our topic is merge sort. We will explain its logic, concept and how it is implemented in DSA. So let's understand what is merge sort. Merge sort is a powerful sorting algorithm classified under the divide and conquer category. It excels in efficiently sorting large datasets by systematically dividing the data into smaller subarrays, sorting them and merging them back together in a sorted manner. Now we will see its concept and logic. Basically, it is in three steps: divide and sort, then recursive strategy and merging process. Dividing and sorting. Merge sort divides the input array into two halves, recursively sorting each half before merging them back together. This process continues until array of size 1 are created as a single element array is inherently sorted. It means that we have to divide the array until the subarray has only one element in it and then merge back together and merge them one by one and sort it then. Now, recursive strategy. The recursive nature of merge sort allows it to break down the complex sorting tasks into manageable operations. Each division reduces the problem size, leading to efficient sorting of the entire dataset once the base case is reached. Merging process. Merge sort's merge steps combines the sorted house into a single sorted array. This step is crucial as it ensures the overall array is sorted properly by comparing elements from both house systematically. Now we will see its step-by-step process of merge sort. Let's trace it. Now take initial array as 12, 31, 35, 8, 32 and 17. We can see this is unsorted array. Now first split this array into two parts equally. In 12, 31 and 35 in the part of 3 and 8, 32 and 17 in these three parts. Now when first the two house is created, then do until all subarrays become one. All subarrays have only one element in it. Like we have divided this in two parts, then divide it in two parts. Further, it only have one, then nothing to do. Then it have two elements, then divide it again until it has only one element. Then do until all subarrays have only one element in it. Then merging process. We have to merge and sort together. Now first we will merge this 12 and 31 and sort them and make array of it. So then 12 and 31. Then we will merge it with 35. So it becomes 12, 31 and 35. Similarly here also 8 and 32. Then merge it with 17, 8, 17 and 32. Now see both subarrays are sorted. Then merge them again. Now sort it again. 8, 12, then 17, 31, 32 and 35. So from this final sorted array will look like this: 8, 12, 17, 31, 32 and 35. So by merging continuous we will obtain the sorted array. Now what is the time complexity, and we will analyze it. So time complexity of merge sort is O of n log n, which applies to the best and worst and average cases. All three cases have same time complexity. This makes it efficient for sorting large dataset consistently. Space complexity. Space complexity of merge set is O of n, primarily due to the use of additional temporary arrays for merging the sorted subarrays. This is an important consideration for large datasets. Stability of merge sort. Merge sort is classified as a stable sorting, meaning that it preserves the relative order of records with equal keys. This stability is crucial for certain applications where order needs to be maintained. Now, my partner will explain its pseudocode and how this algorithm works.
Thank you, Ved. And good morning, ma'am. My name is Varshil Patel, and my ID number is 24CS080. I'm going to explain you the merge sort algorithm using the pseudocode. So let's see. Here we have mainly created two functions, merge sort and merge, to implement the merge sort algorithm. So here here we have the function merge sort, which has attributes like array and integer length and integer right, integer left and integer right. Array is our unsorted array which is passed to the function, and the left and rights are the first and index of the first and the last element of the given array. So first we are checking if our left is less than right, which means the function should have at least more than one element. So uh, it will false if it will false when the subarrays has the single element, when the array will have single element. So in the first line, mid equal to left plus right minus left divided by 2, we are calculating the index of mid elements, mid element, and dividing, and with this two line we are calling the function again, and which are responsible for recursion. So with these two lines we will divide our array into two equal parts, equal, or we can say sometimes both are unequal. We will divide our array into two parts called left subarray and right subarrays. So with this tool, it will recursively calls a function with the subarrays to the subarrays until it gets the arrays which has only a single which has subarrays with single elements. So then it will call the merge function. So what is merge function? Merge function will merge the subarrays into the main array in sorted order. So here in first two line we are calculating the size of left and right subarray, and we will store the values of left subarray into L and right subarray into R, which are two temporary arrays. So then after we will compare the elements of left subarray and right subarray one by one, and whichever and the low and the one with the lesser value will get first into the main array. And if after the all element of any of the subarrays are merged, maybe there are some elements in other array will remains there. For those elements we have implemented this block of codes. If there are remaining elements in left subarray, so this block of code will merge those elements into the main array. And if the right subarrays has the remaining elements, it will this block of code will merge the element of right subarrays into the main array. So let's understand it through the example. So suppose we are passing this array to the function. So the mid element for this function is 35. The first line will pass the left subarray, which is 12, 31, and 35 to the function, and the function will also again divide the array in two parts, which is 12, 31, and 35, and pass the left subarray, which is 12, 31, to again to the function, which is and now again dividing the function into two parts will leads to the single elements of element subarrays with single elements, which is not allowed here according to the base condition. So the first array will be passed to the merge is 12 and 31, which is already sorted. So the function so the there is will be no difference after calling the merge function. And then it will go to the below stack operations. Now we all operations for this array is completed, so the remaining operations of this array will be now continued. So the right sub array of this array is 35, which has no which is the sub array with single element. So so the this array will pass to the merge function, and it is also a sorted element. So the merge function will affect nothing here, but and it then the all operations of the for this subarray is completed. So the function will go to the below stack which has remaining operations of this array. So the right subarray is passed to the function, and it is furtherly divided into two parts, which is left subarray and right subarray, and passed to the left sub and left subarray is passed again to the function. And now it has two elements, so it means dividing the array will get you the subarrays with single elements. So here 82 and 38 and 32 are sorted, so it will though the merge function will return nothing, null function will reflect nothing. So then the operations of this array are completed, and the remaining operations of this array will be continued, and the right subarray of this array will be passed to the function again, but it has only one element, so the function won't call. So the merge function for this array is called. So now we have 832 in we have 8 and 32 in left subarray and 17 in right subarray. So we are comparing the first element of both arrays, 8 and 17. So here we can say the 8 is the lesser than 17. So we will put the 8 first in the main array, then move forward to the next element, which is 32. Now we are comparing again 32 with 17, where the 17 has the lowest value. So the 17 will get into the main array. So now all elements of right subarrays are merged here. Uh, but the left subarray has the remaining element. So with this block of code, the remaining element of left subarrays will be merged into the main array. So 32 will merge into the this array. So now we have two sorted subarrays: 12, 31, 35, 8, 17, 32. So now this whole array will be passed to the merge block, which has two subarrays, 12, 31, 35 and 8, 17, 32. So the merging operation will be applied to this two subarrays. So first it will compare 12 with 8, where the 8 is lower, so it will get the place into main array. Now 12 will compare to 17, where 12 is the lower, so it will get placed. Then comparing 31 and 17 will 17 will get the place, and comparing 31 and 32, 31 will get the place, and then comparing 31 with 32 with 35, 32 will get the space. Now the uh, all elements of right subarrays are merged, but the left subarrays uh, left subarray has remaining one element, which is 35, which will merge into the main array using this block of code. So now we have the sorted array with elements 8, 12, 17, 31, 32 and 35. So this is how the merge sort algorithm works. I hope you understood that pseudocode. It may help you to implement the programming code. So now let's talk about the advantages and disadvantages of merge sort. Merge sort offers several advantages that makes it a preferred choice for sorting algorithm. Its stability ensures that equal elements maintain their relative order. The algorithm performs consistently with a time complexity O of n log n, regardless of input case. This efficiency makes the particularly effective for handling large dataset where other algorithms may falter due to performance issue. Despite of strengths, merge sort has notable disadvantages. One of the significant drawback is its requirement for additional memory, as it utilizes temporary arrays during the merging process. Additionally, the use of recursion can lead to the overhead, which may affect performance, especially in environments with limited stack space. So this was our topic, merge sort algorithm. I hope you understood the topic, and thank you.